So section 2.6, all right, we're moving on. So rational functions and asymptotic behavior, you might have had probably a little bit less experience with rational functions. Probably did more with polynomials. So what's the key word in, what word do you see in rational? What? Ration, think more math. Yeah, so ratio. So you're going to see rational functions are the same as saying fraction functions. So a rational function is a polynomial over a polynomial. Now, the only thing is the numerator can be a 0-degree polynomial. What do I mean by a 0-degree? What's a 0-degree polynomial?
1.
Yeah, like a constant, just like 1 or a 6 or a 2. So the top n is 0 or greater, and the bottom n has to be greater than or equal to 1. If we're talking about our degrees, we're looking at our degrees. So because what I'm saying is this, for instance, let's say the top is just a 3, the bottom is x minus 2. That's a 0-degree, that's a first degree, that's fine, that's a rational function. If I flip it, now I'm going back to a linear function, and rational functions are in a different family than linear, okay? So they're not the same as linear. So for instance, if the x minus 2 is on top and the 3 was on the bottom, it would not be considered a rational function. Okay, so what I want you to first do, the first thing we should be able to figure out is the domain. So I want you can use your graph, you can look at the equation. I want you to figure out what's the domain for this rational function. And then let's talk about the end behavior of the graph. Just like on polynomials, one of the first things we looked at was end behavior. We're going to look at the end behavior on these rational functions. So I don't have a screen to put on a calculator screen to put on the board, but luckily I went to Walmart and got a TI Armand the other day, and it grabs these rational functions for me, so I don't really need them. So I know what the graph is. The graph should look something like this. I know mine's not broken. Okay. All right. Now I went ahead. Your calculator doesn't put this dash, right? But I went ahead and put it for you because you can't see it. You just see this. This is what you see, right? But the dash helps. Okay. So let's talk about the end behavior for this graph. End behavior means as x goes to infinity, what does y go to? And as x goes to negative infinity, what does y go to? Now, what I want you to see is this is not going down forever. It's leveling off towards something. And as we go off to the right, it levels. It doesn't keep going down. As we go off to the left, it levels off. So our end behavior this way, I want you guys to see is your y is leveling off. So that means we're approaching a y. So it's not going to infinity or negative infinity. It is going to, the y's are going to infinity somewhere. You see, there's only one place that the y's are going to infinity. There's only one part where the y's go to infinity. Do you see it? Right here, that's exactly right. As we're trying to get close to this number here, it's going up to infinity. That's the only spot. And there's one place where the y's are going to negative infinity. Do you see that? Same spot right here. So now let's talk about this. There's two types of asymptotes, and an asymptote serves as a guide, and it tells you what the graph is approaching. It's like a boundary that's there that you get close to that but never reach. So what you don't see is that, and what was the domain of this, by the way? all real except 2. Notice you cannot plug in a 2, right? All real except 2. So it would be helpful if I put this dashed line here at 2 to highlight that, yes, here's what's happening. Y is going to infinity as we get close to 2. As we get close to 2, it's going up like this. And as we get close to 2 this way, it's going down to negative infinity. And this is called a vertical asymptote. And x equals 2 is the vertical asymptote. X equals 2 is the boundary line. So what I got to get you to get to is, how are you going to know that? Like, how are you going to be able to look at the function and know what the vertical asymptote is, right? Now, is there a shortcut? Now, here's what I want you to see numerically. If I made a table for this, and I plugged in, say, a 3 over here, and I plug in a 3, I get 3 over 3 minus 2, and I get 3. And if I plugged in a 2.5, I get 3 over 2.5 minus 2, which is 6. Makes sense? It's climbing up. If I plug in a 2, what happens? Can you divide by 0? Now, I told you what my professor told me in college, right? Yes, no? You divide by 0. Not good. 3 divided by 0 is called undefined. Well, we know that there's no point there anyways, okay? But now I want you to try to connect the picture and the equation and the function, right? We look at this. Remember, we're going to need to find the vertical asymptote. What's the one number you can't plug in? 2. What happens to be the vertical asymptote? Okay? All right. But let me show you what happens here numerically. Let's go a little bit right of 2, like 2.1. So notice, the closer I get to 2, the smaller the denominator gets. See, I get 3 over 0.1, which is 30. 2.01, I get 3 over 2.01 minus 2, which is 3 over 0.01, which is 300. So what's happening is, here's an asymptote is, the word approaches always has to be used. As x is approaching 2, see, I'm getting close to 2, 2.1, 2.01. Look at my y's, 30, 300, 2.001. I would get 3 over 0.001, which is 3,000. So just look right here. As my x's get close to 2, what are my y's going to? That's infinity. That's exactly right. And that is how you know you have a vertical asymptote. That's what's happening. So a vertical asymptote is vertical in behavior. The y's will go to infinity and negative infinity at a vertical asymptote. The question is, can you find it on your own quickly? You know, is there a shortcut? That's what you want to be able to find. So what I'm going to do is, so notice at our vertical asymptote here, we can see this. We looked at it numerically. And we also see that x cannot equal to 2 from the equation. If you plugged in a 2, you would divide by 0. So does everybody see how all those kind of tie in? All right. Now, there's also another asymptote because the graph levels off this way. Now, we're going to get to that later, but what do you think that one's called? Horizontal asymptote. See, this is a horizontal. Okay. So I'm going to put 3 or 4 equations on the board. All I want you to do is see if you can figure out where the vertical asymptote is. Remember, this is what has to happen. As I get close to that vertical asymptote, the y's have to go to infinity or the y's have to go to negative infinity, so you can look at your chart there. All right, so let's do a couple of problems. And it would be helpful if you kind of calculate the domain too. So at a vertical asymptote, let me just write this generically real quick. And look, it it could be like up on this side, down on this side. It could both be up. As long as we're going to infinity or to negative infinity, it's a vertical asymptote. So what's the graphical definition? So vertical asymptote. Hey, I'm going to tell you right now, I'm going to give you this lesson in doses. We're going to just do vertical asymptotes and holes, and we're going to stop today. So we make this lesson, we'll go into next week. It's okay. All right. Vertical asymptote. So x equals to a is a vertical asymptote if, as x values approach a, y values approach infinity or negative infinity. That is the definition. That's how you know you have a vertical asymptote. Now that's more of the graphical definition than the numerical. That's not the equation definition. Okay, so here we go. Here are some graphs for you to do, and I want you to look for the vertical asymptote. All right. So you have three functions. I will tell you this, all three have vertical asymptotes. I would like the equation. So all I want you to do on each one, look at your graph, look at the picture, put VA x equals what? VA x equals what? VA x equals what? Okay? And see now if we can come up with a shortcut on how we can just look at the equation. Now remember the one we did earlier, what do we have? 3 over x minus 2, and the vertical asymptote was x equals to 2. So one thing I'm looking for is what's a shortcut to find a vertical asymptote, okay? All right, go ahead and take a second and do those. I'll try to draw the picture the best I can for each one. So is it supposed to rain all day? Hey! Thank you. Yeah, one there. Oh, that's all right. Oh, the dentist or what? Oh, okay. Wow. Yeah. Oh, okay.
What kind is it?
Venti iced coffee, add a shot of espresso, sugar-free vanilla, and half and half.
Sounds horrible.
What?
Sugar-free vanilla?
Yeah. Sugar's bad for you. Guess what? It can sound horrible to you, but I like it.
They don't give straws anymore. Don't you hate that? They don't get used to it.
Sorry. Okay, so let's look at this. So we'll graph each one and pretend their calculator's graphing it. So the first one, what did you notice? There's two. There can be more than one vertical asymptote. So what did you get for the vertical asymptotes on the first one? That's exactly right. Right? Is it a coincidence that -3 and 3 make the denominator 0? What do you think? Yeah, that's what we're trying to find out, right? I think this one looks like this. All right, is this the picture? Is that what you got? Oh, well, you're supposed to graph it, silly goose. Did anybody graph the first one? Is that what it looked like? Yeah, okay. Because I want to just, good. Now I'm going to get you. All right. So now, next one. What did you guys get? What's the vertical asymptote? Okay, -5. And that picture, my markers are dying. Good spots. -5. So you should have seen this. And let's see, it was like this, something like this. Is that about right? Something close? Is that close to what you saw? Okay. All right. What did you get for the vertical asymptotes for the third one? Anybody else? Graph it on your calculator. Tell me what you see.
According to the calculator, it's only 2.
Not only according to the calculator, according to all the mathematics, it's only x equals -2. There's not 2 vertical asymptotes. I've set a trap for you. Okay? So notice the title on the first bullet point. It said vertical asymptotes and holes. Now, we're right. Notice these make only the bottom 0. This makes only the bottom 0. This makes only the bottom 0. But now notice, so if you look at this picture, so I'm going to go ahead and do my best to graph this one. Sorry, so let me, for the people at home, so let me try to highlight this picture a little bit. All right, so here's what I would ask you to do, and for you guys here. Type this in, but do a zoom decimal, and a lot of times zoom decimal will show your hole. It'll show that when you have a hole in the graph. So let's see. So 1, 2. It may be hard to see, but that's the picture. If you try zoom decimal, did it show a little gap right here? Yeah. So notice this one has a vertical asymptote at x equals -2, and as everybody see, it has a hole at x equals to 2. Okay. See, at 2, it has a hole. And so Zoe pointed out what was different about this one. Yeah. So if we factor this, so real quick, we want to, this is the graph here. We see that this is x is 2. If we factor this, it's not x squared plus 4. Sorry. the bottom factors x minus 2, x plus 2, and anytime you have the same factor in top and bottom, that represents a hole. That's going to tell you that there's a hole in the graph, not an asymptote. And there's a hole at x equals 2, okay? Whatever makes that hole, okay? Whatever makes it 0 over 0. Whatever is only in the denominator, now, naturally, what would you do in math? What do you feel you should do? Like if you had the same thing in the top and bottom, what would you do? Cancel. So really, this is the graph of 1 over x plus 2 with a hole at 2, because at 2 is what made it 0 over 0. And now, if you looked at this, Molly, then you would say, yes, vertical asymptote is negative 2. So what doesn't cancel is a vertical asymptote. I think we've got that now. If it cancels, we'll have a hole. So the way I kind of write this is this. Like, let's say I had y equals x minus a over x minus a times x minus b, right? So here's what I would say. So we would have a hole at x equals a, because that's a common factor in numerator and denominator. And then what I typically do is I would cancel, and I'm left with 1 over x minus b, and then whatever's only in the bottom, so if it's only in the denominator, so the factor that is only in the denominator represents a vertical asymptote. And that's the difference. Okay? So you may need to factor. You may need to have the ability to factor. See, because x squared minus 4 factors x minus 2x plus 2. So here we go. I'm going to give you one. Let's try not to use the calculator. I'm going to give you one last equation. Can you find the holes in vertical asymptote? So here we go. All right. So here's what I want. I want any holes and vertical asymptote. So what skill might be required in working this problem? Yes. Okay. So factor the top, factor the bottom. Remember, if we have the same factor in top and bottom, it's a what? Oh, only in the bottom, it's a what? Vertical asymptote. I'm not going to graph that. We're just going to write down the answer. Okay, how does the top factor?
Minus 2, minus 3.
How does the bottom factor?
That's plus minus 3.
All right. So our common factor is the x minus 2. So that means we have a hole where? Hole at x is 2. I will then cancel and see what I'm left with. And I'm left with only an x plus 1 in the bottom. So therefore my vertical asymptote is what? So what's the x minus 3? Well, it's not a hole or vertical asymptote, I can tell you that. Okay, it gives you something else, so think about what that does. All right, now if we want domain, you would still have to say now, Haley L, we would say all real except what? So go back to the start. Remember, you can't plug in a -1, we know that. You still couldn't plug in a 2 because it blows up the whole problem. It makes it 0, 0. So both of these you still gotta take into consideration. So if we said domain, it would be all real except what? Yep, all real except -1 and 2. How do you write that in interval notation? How do you say everything but -1 and 2? Yeah. Union. Bit of a pain, but that's how you do it. That means it, so for me, it's easier to write it like that. Okay. So going into this lesson, and it'll be open, you can go, remember you got unlimited attempts. You can go in and start messing around with it, but we'll finish this up into the week. Vertical asymptotes and holes, can you find those from the equation?
Yeah.
Yes. Horizontal asymptote, we haven't done yet. I'm gonna stop there because you got a quiz that's out. I want you to finish this last homework. So we'll stop that there.